So we're going to start chapter 1, which in a sense, chapter 1 is kind of a broad overview of the whole book. Today we're going to work on solving systems of equations by graphing. And we're going to graph in two ways. I'm going to have you start out by graphing them kind of freehand, sketching them, making sure, just kind of reviewing your graphing skills a little bit to make sure you can graph, and then show you why it's not always the best way to do things, and you'll figure that out rather quickly, why it's not the best way to solve these systems of equation, especially doing it by hand. And then I'll introduce you to a tool if you haven't used before, Desmos, that graphs for you, that makes life a whole lot easier to do. So if we're solving these systems of equations by graphing, the first thing we probably need to define is, what is a system of equations? So for your notes, a system of equations. Systems of equations is a set of two or more equations with the same variables. So as you're kind of writing that down, you're going to have two equations where you want the solutions to be the same. A great example of this would be like the ticket takers down at the basketball game. You know, they know it costs $4 for $5 for a student to go and $10 for an adult. So if I know on one day I made $190 and on the next day I made $230, but I forgot to take the tickets out, I can solve that system to figure out how many adult tickets I sold and how many student tickets I sold. By solving that system of equations. So in this case, we've got the two systems. Y is equal to 3x minus 1 and y is equal to 1/2 x minus 6. Plus 6. What we want to come up with then is what we call a solution to the system. The solution to the system is an ordered pair. And the key thing with that ordered pair is that ordered pair is going to work in both of the equations. So if I were to plug that solution in that I find, it's going to make both statements true. So in the above system of equations, the solution to the above equation is 2, 5. So what we can do then is we can check, in fact, to see if that is the true solution by substituting my y value with a 5 and substituting my x variable with a 2. 5 does, in fact, equal 6 minus 1. So I know that works for the first equation. If I plug it into the second equation, my y value is still going to be 5. My x value is still going to be 2. But now it has to be negative 1/2 times 2 plus 6. Well, negative half of 2 is negative 1. Negative 1 plus 6 is 5. So it works out. So that is my solution to this system. This is kind of the nice part about taking tests. If they're asking you for the solution of a system of equations and it's multiple guess, multiple choice, you don't necessarily need to know how to solve the system of equations to find the answer. You can look at the answers and work backwards. If I would have said 2, 8 is a solution to this, if you plug 8 in for y and 2 in for the x, it doesn't work. So you know you can go to the next one. So sometimes it just takes test-taking skills. And that's one of the nice things about systems of equations with this. Now, within systems of equations, there are two special types of special cases. That's if the lines are the same. Okay, if the lines are the same, there's what we call infinitely many solutions. If they are the same line. So, for example, if your equations were y is equal to 2x plus 4 and negative 2x plus y equals 4. If I were to graph those two equations separately, I would have the same exact line. And there are infinitely many solutions to that. They're the same line. So any value I put in for x and y, it's going to work for both equations. If the lines are parallel, there are no solutions. if the lines are parallel, there are going to be no solutions. So if I had something like y is 3, y is equal to 2x plus 4, which is probably about what that one is, and y is equal to 2x minus 8. Those two equations are never going to intersect each other. So they have no solutions to them. Okay, so those are the two special types of cases you could have. They're the same line, infinitely many solutions, or they're parallel to each other and there are no solutions. How do we go about then doing this? What's the operation for doing this? To solve a system of equations by graphing, you have 2 steps. Well, 3 because there's 2 parts to the first step. But first thing you're going to do is graph both equations on the same coordinate plane. That's step 1. Is you're going to graph both equations on the same coordinate plane. So we have 2 equations here. We have y is equal to negative 2x minus 1. And we have the equation y is equal to x plus 5. Those are our 2 equations. That's our system. So the first thing I'm going to do is I'm going to graph them. So I'm going to start out by graphing y is equal to negative 2x minus 1. So from last unit, we know that our y-intercept is the point 0b. So my b value is negative 1. So there's my first point, is at 0, negative 1. So I'm going to put a point at 0, negative 1. And then we also know that our slope of this is negative 2. So negative 2 over 1. So that means my next point is going to be down 2 and over 1. Now, if you've got graph paper, you've got straight edges, and you have all of those nice things, you can draw this nice straight line. So that's the graph of the first one. Doesn't look very straight in my mind because it's probably not. Now we graph the second one. The second one is y is equal to x plus 5. Our y-intercept, again, is 0b, so it's 0, 5. Put a point at 5. My slope is 1, or 1 over 1. So that means I go up 1 over 1. There's my points. I draw the line. So we've got both of them drawn. That's the first part. Second part then says that your solution is where the 2 lines cross. So these 2 lines cross right here. That's the ordered pair in this case, negative 2, 3. Now here becomes the problem with graphing. You have to be very, very accurate when you're graphing. I've got graph paper sitting up in front of me. I wouldn't even trust myself to know if that's right or not. Okay? The only way I know if that's right or not really is if I check it. So if I check this one, I plug it into the first equation. That gives me 3 is equal to negative 2 times negative 2 minus 1. So that's 4 minus 1. So that's 3. So it works for the first one. For the second one, it'd be 3 is equal to negative 2 plus 5, which is 3. So it works for the second one. So I know that's my solution. Now, I was careful. I was careful last hour, too, when I did this question. That's not the answer I got when I did it the first time in last class period. Last period when I did it, I got an answer of negative 3, 2. Because I wasn't accurate with my graph. So I checked it and it was wrong. So then I had to readjust what my graph looked like, making sure that my lines were actually straight. They weren't straight. Okay? So moral of the story, when you're graphing these, you have to make sure you're very, very, very accurate. Okay? Let's look at another one. maybe. So let's look at y equals negative 4. And y is equal to 2x plus 4. So again, we've got two equations, y equals negative 4 and y equals 2x plus 4. So the first thing we're going to graph is y equals negative 4. We've talked about this a lot last week. We know our y value always has to be negative 4. We don't care what our x value is. Just give it a couple of points. But the y value always has to be negative 4. So 0, negative 4, 2, negative 4. Draw a nice straight line. Again, making sure it's nice and straight. We do the second one. 2x plus 4. Our y-intercept is 0, 4. Oh my gosh, it's way up there. And my slope is 2. So it's 2 over 1. Everybody knows where I'm getting all those, right? That was last week. So that means I go up 2 and over 1. So I draw this line. That looks somewhat straight to me. It's not even close to straight. That's straight.
Why don't you just do all the points every time?
See, and then there becomes a problem, and great job. That was my point. The next way to make this accurate is to do every single point down here possible until you get to where you have to be, which is right there. And that's the point, negative 4, negative 4. And that's your solution. Okay. Here's the point of all of this. Graphing these, it's unrealistic. Graphing these on a sheet of paper that I don't provide for you, even if I provide a piece of graph paper for you, is very, very hard. I've got one sitting right in front of me, and I can't draw straight. I ain't gonna put a straight edge up there. I'm too lazy. If I'm too lazy, most of you probably are too. Maybe not. Maybe not. So what do we do instead? There's this handy dandy little thing out there called Desmos. Desmos should become your friend during this thing. The question becomes, and I talked about this with two math teachers as between hours here. We talked about what's the point of this lesson. See, math teachers, we talk every once in a while. So what's the point of the lesson? It's the point of the lesson that you're able to graph. And if you're in algebra, yes, maybe. You should be able to graph at this point in your lives. If you can't, come get some help. The point of this lesson is to figure out what the solutions are. The solutions are found by graphing. But when you have other tools, you can use other tools. And Desmos is what we can use to solve these systems by graphing. This is what you can do inside Desmos. And this is either an app, or you can just type Desmos into your search engine on your computer. Will I let you use Desmos on your test? Yes, I will.
On our phones or on our computers?
On your computers, not on your phones. Because you'll get through it quick, and then you're going to close your computers. Then I don't have to have you turn your phones back in. Okay, but you'll be able to use it on the test real quick. So, if we use Desmos, let's go to the next question. Next question looks bad. It's 2x minus 3y equals 3. Okay, graphing that, yeah, whatever, solve for y, do all of that. You could do that. Blah, 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 blah. Okay, my suggestion for you is that we're going to go into Desmos. Inside of Desmos, all you have to do is put 2x and have a better memory than me, because mine's horrible, minus 3y. So 2x minus 3y equals, anybody remember? 3? Equals 3. There's the first one. You click the number 2. You do the second one. Second one, anybody remember what? Negative x plus y equals what? Negative 2. There are the two equations. You zoom in. You understand the concept of where they intersect is your solution. You click on that point right there. It tells you it's the 0.31. And you're done. And you move on. Okay? And that's what I want you to do today. I want you to graph these inside of Desmos when you're doing these. I don't want you to worry about graphing it on the graph paper. I don't want you to do any of that. I want you to graph them inside of Desmos, understand the concept of where they intersect is the solution that you're looking for, and all you have to do is give me that point of intersection on your assignment today. The next one, I can make it harder. Is that good enough?
I think we're good.
Do I need to do any more then?
Nope.
Desmos is a good thing?
Yes.
Yes, Desmos is a very good thing. Okay, and again, even that, just plug it in. I suspect those are parallel to each other. Remember, if they're parallel, they don't intersect, so 5x plus 2y. So if we have 5x plus 2y, it doesn't even matter. I'll say equals 8, and 5x plus 2y equals negative 2. See those two graphs, how they don't intersect? You'd be no solutions, okay? So use Desmos today to help you graph them, for you. You find that right inside of, just type in Desmos graphing calculator. Again, there's an app for it. I would get the app and put it on your phone. I won't let you use your phone on assessments, however. Let you use your computer real quick to do those two problems, and then you'll move on. And you put the computer away.